Hi everyone, good evening. In this lecture series, we are going to see about the topic vestigial sideband. In the previous video, we have discussed about the modulation and what are all the types of the modulation. So we are having the amplitude modulation, frequency modulation, and phase modulation. We have discussed about that. The next part we are going to discuss about the vestigial sideband. So it is one of the applications of what we are using in the TV transmission system. So here the vestigial sideband, it is one of the modulation technique. It allows the transmission of one sideband in addition with the part of vestige of the other. So we are having so many techniques in the amplitude modulation. We are having the double sideband. The next one, the double sideband suppressed carrier, single sideband, and the last one will be your vestigial sideband. So we have discussed about what do you mean by amplitude modulation and why this VSP techniques was introduced means some of the drawbacks will be available in the single sidebands. We have discussed about the two sidebands, that is LSB and USB. In SSB modulation, it requires the accurate frequency response. So here in vestigial sideband, we are having two sidebands. One is upper sidebands and lower sidebands. So here one sideband fully it takes for the transmission purpose. From the other sideband, it will only take a portion. So that is termed to be as your vestige. So here, let us see the block diagram of the vestigial sideband. So here we are having balanced modulator, sideband filter, linear amplifier, power amplifier. Another one will be your carrier oscillator. So here the modulating signal is the message signal that is given to the balanced modulator. The carrier signal, we are generating the carrier. So both gets multiplied in the balanced modulator. And finally, the output of the balanced modulator will be your double sideband suppressed carrier. And it is given to that of the sideband filter. So the output of the sideband filter will be the vestigial sideband and it is given to that of the linear amplifier. Finally, it is given to that of the power amplifier in order to increase, that is loss, to compensate the loss. So that will be the output of your power amplifier. So this is the generation of the vestigial sideband. While coming to the spectrum of the message signal and VSP, so the first diagram represents the spectrum of the message signal and the next one from the figure itself, the full USB has been transmitted. In the other part, only part has been taken. So that is termed to be as your vestige. So the center frequency will be FC. The full USB that has been transmitted, it is taken as FC plus FM. Here the full USB has been transmitted, that is FC minus FM. So here the part of the LSB have taken. This is termed to be as your vestigial sideband. So let us take the TV transmitted signal. So we are having the various frequencies. Suppose for the TV transmission, we have to measure the picture clarity carrier, sound carrier, what is the spectrum, what are all the channel frequency we are using. So in this diagram, we have represented some of the frequency ranges for the television signal that has been used for the VSB transmission. So this is the diagram. It relates to the amplitude with respect to that of frequency. While coming to that of the advantages of vestigial sideband, it is very efficient modulation technique. It is used for the wave transmission. It reduces the bandwidth utilization. The filter characteristics will be accurate and the design will be simple. The low frequency components, good phase characteristics. While compared to that of the disadvantages, its bandwidth required is somewhat higher due to the prestige and it is one of the D complex modulation process at the receiver. So while coming to that of the applications of the VSB for the transmission of the television signals, the VSB technique is widely used, and the signals there will be a simultaneous transmission of the audio and the video information, and the bandwidth of the video signal will be 4.2 megahertz, and it will be multiplied with 2, we will get 8.4 megahertz. So while coming to that of the conclusion, it achieves the bandwidth efficiency and the utilization, it offers better quality. And these are all the assessment questions of the vestigial sideband. Thank you.